Hello. Um, my name is Jakub. You probably know me as Jakpan. I'm CTO of Intergalactic, which is building Hydra DX, or maybe better say hydration. Um, and I'm gonna answer this question hopefully today. Why XCM rate limiters? Um, so we definitely don't want to end up on this page. There is a lot of hacks, bridge hacks, governance overtakes that happened during the past years. And we should all do as much as possible to protect our users from toxic liquidity or being hacked. So how to protect your chain? You could do KYC, which probably we don't want to, and it probably won't stop any hackers from putting money on your chain. So why XCM rate limiters? You should always do audits. You should always do some mechanisms on your protocol that will make sure that you are as secure as possible. But in the end, for most parachains in Polkadot, the XCM is often the first and last layer of defense because all the messages pass through it and are being executed. So what can we do here? One way of protecting yourself is building an XCM barrier. And barrier is a simple filter basically that says if given XCM, a message or program should execute or not. So the message is, this is like a simple barrier that checks if you have a right origin and you are paying fees, and you don't see all the code here, but this just checks yes and no. If no, the message is not even processed on the chain. So then there is XCM execute filters, which is a little bit more complex. It is a filter on XCM execute instruction, which can call arbitrary code on your chain. So what you can do is you can disable or enable any functions that other parachains would call on your chain, and based on some complex logic. For example, this one, this is just a you see allow transfer and swap. You don't see all the code here, but it checks, it allows executing transfers and swap through XCM execute basically. And it has some other filters like maximum depth, maximum number of instructions that you can have in XCM message, because it's basically a programming language. And then you could do XCM pausing or deferring, which currently is not really possible without losing the messages. But let's look how this works and how we are imagining it could work in the future. So there is one palette, it's called palette XMPQ, and this palette processes all inbound, outbound, and messages and passes this to XCM executor for execution on the chain. So this is the configuration of the XMPQ palette. You might notice in the bottom there is like maximum deferred messages, maximum deferred buckets, which is configuration for your runtime to not be to not overflow the POV size. But you can see XCM deferred origin and XCM deferred filter, which is pretty important. We'll go to it later. So we kind of took this palette, which is standard Cumulus palette, and plugged the differ filtering inside of this. So what you have here is a trait which contains differed by, and it basically says what is where the message was sent at, what is the message from what chain, and actual XCM, and it returns option like to differ or not differ this message by a certain amount of blocks. So then we have a new thing which is deferred message, which is struct for storing messages in the storage. And basically what you have, it's pretty simple. You have some time period which the message was deferred to. You have the sender and again the XCM so that we can replay the message when it's bound to be. Now, this is a standard function from XMPQ. It's called process XMP message. It iterates through XCM program recursively and executes each instruction. And each instruction has wait, and until it reaches the wait, it tries to execute this instruction. If it's too high, there is something like overweight queue. You put these messages there, but also what you see on the bottom, you run a defer filter on this message, and if the message should be deferred, it's not executed, it's put in the queue. Now this is a function that basically starts executing deferred messages and services the queue. And it's run every time that the chain is idle or when the time is for it, which is in the beginning of the block, which is after processing every normal XCM. Okay, now we have an interesting function which is called discard deferred, and this is used in extreme situations. But if somebody hacked something and is sending some instruction that you don't want on your chain, there is like a execute deferred origin, which you can configure to be either governance or some technical security body on your chain. And if the message was deferred and you deem it dangerous, you can discard it. It's not executed at all. And there is another function which is similar to pause, but we thought, why not? If we have already the storage for these messages, you can defer all the XCMs that come to your chain, and this is for critical situation when there is an ongoing hack going on or breach leaking or something like this. Yeah, and this is what I talked about before. There is a function that services the queues. You can see this is called every on the start of the block, and you can see that first the normal XMP queue incoming messages are processed, and then after all the incoming messages are processed, the deferred queue is processed. Okay, so what about the filter? We didn't talk about this. The filter should protect users. It should not limit them. It should be set to something that normally wouldn't get triggered, and this is only meaning to protect from some extreme situation. You can have inbound and outbound filters. It depends on your use case. For bridges, maybe more important for you to protect the outbound filters, but for something like DEX, it might be more interesting to have inbound, or maybe both. So the filter is implemented in Palette XCM rate limiter, and it triggers the differing action only when the rate limit that we set is reached. It defers all subsequent messages because we cannot say that, okay, this message is small, I won't defer it. The hacker can create 1,000 accounts and then send 1,000 different messages with small amounts and circumvent the filter. So yeah, and the rate limits decays by a fixed amount over time. So that means like the volume is set. We will see this in the next slide. Um, okay, so in our palette XCM rate limiter, we have type, which basically is a getter for asset ID, and it returns a value of balance. And it means how much basically tokens you can you want to rate limit. So for example, you would either set it like statically in the beginning in the configuration for some amount, or you could set it to something like 20% of your daily volume per hour or something like this, to be sure that normal operation is not limited. And then you have the defer duration. It's the time that you defer the messages by. And right now it's set up for blocks. It can be also timestamps if you want. Okay, so tokens are deferred by defer duration only after the rate limit is exceeded. And this means, so if rate limit is 1,000 tokens per 10 blocks, then if you send 1,500 tokens, it gets proportionally deferred by 5 blocks because you overshot only by 50%. Each subsequent message is going to be deferred by this amount. And the accumulated amounts which we store decay linearly at the rate limit. So if you have rate limit 1,000 tokens per 10 blocks, it means that every block you can send 100 more tokens through the rate limiter. And you can imagine it like this. The blue number 1 is like a first block and one message. It didn't reach the limit of the rate limiter. And in the second block, you can see that, so it's executed, the message is executed. In the second block, you see there is still like some decaying amount of the rate limiter, and there are two messages. One is past the differ filter, and the second one is small, but it's still past the differ filter, so it's also getting delayed. And in the next block, again, the rate limit decayed, the messages from the previous block were executed, and you can still send some amount in this block. This is the way which we can protect our chains from toxic flow without impacting UX of the users. Because if you set it to something sensible, the messages are not lost, and it's sometimes just delayed if there is something happening. So we still have something to do here. We need to net inflow and outflow volume to prevent DDoSing the rate limiter. And we would like to then propose this as optional standard to XCM so that you could use it if you wanted to. So thank you. Stay hydrated, not liquidated. And if you have any questions or you want to talk about this, then I'm here.
Yeah, actually, I wonder how you, afterward, just send those different tokens to the users after that the tokens are differated. Maybe I missed the start of the presentation. I don't know.
It's not the tokens are held, but the message is actually not executed. So if the message inside has deposit tokens on the chain, the whole message is deferred and executed later. So that means from one chain you transfer the tokens, and we still have the information that you want to deposit the tokens, but it's not done in the point in time, just later.
Yeah, how we triggered that? Like, do you trigger it in block finalizations or block initialization?
No, this is actually part of the XCM execution, like XCM PQ, which is a standard thing that is inside of the all parachains have this palette implemented
Okay, I understand.
that uses XCM.
Okay.
Just to clarify, did you fork the XCMPG
Yes.
palette? Okay,
Yeah.
cool, great.
Currently it's forked, but we would like to push it back if it's possible.
Maybe from my side, then I'll pass over. Isn't the rate limiting per se already kind of a DDoS attack vector or DOS attack vector? Because you could limit normal users to use it by just starting to spam the chain, right?
Not really, because if you net the inflow and outflow of the token, you can send it back and forth, but the rate limit would stay at 0 because you are just sending tokens back and forth. If this was not the case, yes, you could DDoS the chain by blocking all the transactions.
Maybe you could add some proof of work or something to the messages, I don't know, at some point. Cool.
Yeah, thank you. But that was basically my question too. I was wondering about the possibility of DDoS attack if I spam the network with a lot of messages.
Yeah.
What happens to the messages?
Yeah, basically, it's not about number of messages, but it's about amount of value that you are transferring. So if you want to spam the chain, you need to have a lot of value, and that is expensive. So you can for some time, but it depends if it's.
Okay.
And another thing is that you can also resume execution if there was some valid, I don't know, actor that want to add a lot of liquidity and it was accidentally triggered. You could resume execution on demand.
Thank you.
Does anybody have any questions? Okay, so that's it. Thank you, Jakub.
Yeah, thanks.